So, fully expand p plus q to the 5. So there's some factual knowledge required for this. So we've got to learn a plus b to the n. You might be able to look it up. Well, it will be in the formula book as well. And you get n0 or nc0, if you prefer that notation, a to the n, plus n1 or nc1, a to the n minus 1 b, plus n2 a to the n minus 2 b squared, plus dot dot dot, and it keeps on going until you get to the end where you've got n b to the n and a to the 0, and a to the 0 is 1, so we don't bother to write that down. So now we've got to transfer that knowledge into this context. So we've got p plus q to the power 5. So we get n0 p to the 5 plus n1 p to the 4q plus n2 p cubed q squared plus n3 p squared q cubed plus n4 p q to the 4 plus n. Why am I writing n in all of those? That should have been 5 to the 5, q to the 5. Now, can I just rob out those n's? And they should have been all be 5, shouldn't they? 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. Sorry about that. Okay, so you can now use the calculator, the NCR button, to find this, or you could use Pascal's triangle, etc. Or you might just know the 6th row, the fifth row of Pascal's triangle, depending on whether you count the one at the top. So we get p to the 5 plus 5p to the 4q plus 10p cubed q squared plus 10p squared q cubed plus 5p q to the 4 plus q to the 5. Okay. So the coefficients at the front are the values that you get out. Yeah, so the coefficients at the front here are the values that you're getting at from your NCR on the calculator or the row of Pascal's triangle. Now let's read the rest of the question. Let P represent the probability that the number 4 is rolled on a given roll. It's a fair 4-sided dice, numbered 1, 2, 3, and 4, and it's rolled the 5 times. Let Q represent the probability that the number 4 is not rolled, so Q is not rolled. So the probability of P is the probability. So P, probability of a 4 being rolled must be a quarter, and Q, the probability of not being rolled, a 4 not being rolled, is 3/4. And we want, using the first 3 terms, so that's these 3 of the binomial expansion from part A, or otherwise find the probability that the number 4 is rolled at least 3 times. So P is the probability of getting a 4, so that is 5, this here is 5 4s in 5 rolls. This one is going to be 4 4s in 5 rolls, and this one's going to be 3 4s in 5 rows. I hope that makes sense. Yeah? Because P is the probability of a 4, and it happens 5 times there. And the second one, there are 5 different ways, yeah, so we can get the not 4 first roll, or the second roll, or the third roll, or the fourth roll, or the fifth roll. So there are 5 different ways that we can get 4 4s on one non-4, etc. So the next one says there are 10 different ways that we can get 3 4s and 2 non-4s. So what we want from this answer is using the first 3 terms, or otherwise find the probability that the number 4 is rolled at least 3 times. So at least 3 times is those 3 added up. So probability of 4 at least 3 times is equal to P, which is 1/4 to the power 5, plus 5 lots of 1/4 to the power 4 times 3 quarters, plus 10 1/4 cubed times 3 quarters squared. Okay, so now 1/4, 1/4 to the power 5 is 1/2 to the 10, which is 1/1024. 1/, you can use a calculator, plus, well, the bottom again, we've got 4 to the power 5, so that's going to be 1024. 1024, and on the top we've got 5 times 3, which is 15, plus again we've got 4 to the power 5, which is 1024, because that's the same as 2 to the 10, and on the top we've got 10 times 3 squared, which is 90. So this is equal to 106 over 1024, which simplifies to 53 over 512.